close your eyes for a moment and imagine this. Right now, as you're listening to my voice, you are traveling through space at 828,000 kilometers per hour. You're not sitting still. You've never been still, not for a single moment of your entire life. And here's the part that will change how you sleep tonight. The universe has been rocking you to sleep since before you were born. What if I told you that the gentle rhythm you feel when you're drifting off to sleep, that sensation of floating, isn't just in your head? You are floating. We all are. And the solar system, this magnificent cosmic cradle, has been orchestrating the most elaborate lullaby for 4.6 billion years, and you're finally about to hear it. Tonight, I'm going to share something with you that astronomers have known for decades, but rarely talk about in these terms. Our solar system isn't just a collection of rocks and gas orbiting a star. It's a perfectly balanced music box, a cosmic symphony of gravitational rhythms, electromagnetic whispers, and mathematical harmonies so precise that if you changed any single note, none of us would be here to listen. But here's what will blow your mind. When you understand these rhythms, when you truly comprehend the gentle forces that have cradled Earth for billions of years, sleep becomes effortless, because you realize you're not trying to fall asleep. You're surrendering to a dance that's been going on since before there was anyone to dance. Before we begin this journey together, I need you to do something for me. If you're ready to discover why the solar system is the universe's most elaborate sleep aid, hit that like button. Subscribe to this channel, because over the next 3.5 hours, I'm going to fundamentally change how you think about bedtime. And drop a comment telling me, what country are you listening from? And what time is it where you are right now? I want to know where in the world people are finally learning to sleep with the cosmos. Let's begin with the gentlest force in the universe. Here's something your science teacher probably never told you. Gravity isn't pulling you down. That's not what gravity does. Gravity is the universe's way of embracing you. Right now, the Earth isn't holding you against its surface through some aggressive force. It's curving space itself around you, creating a gentle pocket in reality where you naturally rest. The mathematician Albert Einstein figured this out in 1915, and when he did, he literally couldn't sleep for weeks because the implications were so beautiful. He called it general relativity, but here's the surprising twist. What he discovered was that massive objects don't pull on you at all. They bend the fabric of space-time, and you simply follow the curves, like a marble rolling on a stretched sheet. Think of it like this. Imagine you're lying on a waterbed. When someone sits on the edge, you don't feel them pulling you toward them. You feel yourself naturally rolling into the depression they create. That's exactly what Earth is doing right now. It's creating a depression in space-time, and you're resting in that depression as comfortably as you rest in your bed. But Earth isn't the only thing creating these cosmic curves around you. The moon is doing it too, and the sun, and Jupiter, and every single object in the solar system. Right now, you exist at the intersection of billions of overlapping gravitational curves, each one pulling you in a slightly different direction, each one so perfectly balanced against the others that the net effect is peace. The astronomer Johannes Kepler discovered in 1619 that planets don't just randomly orbit the sun. They follow precise mathematical laws, what we now call Kepler's laws of planetary motion. He found that every planet's orbital period squared is proportional to its average distance from the sun cubed. When he discovered this, he wrote in his notes, "I am stealing the golden vessels of the Egyptians to build a tabernacle to my God." He was so overwhelmed by the mathematical beauty that he wept. But here's what Kepler didn't know, what nobody knew until much later. These mathematical relationships aren't arbitrary. They're the only possible stable configuration. Any other arrangement, and planets would either crash into each other or spin away into darkness. The solar system found its perfect balance through 4.6 billion years of gentle adjustments, and now it maintains that balance with the precision of a master clockmaker. Your body knows this rhythm. It evolved in this rhythm. The 24-hour day, the 29.5-day lunar cycle, the 365.25-day solar year. These aren't just numbers on a calendar. They're encoded in your DNA, your circadian rhythm, the biological clock that tells you when to sleep, evolved to match Earth's rotation. Your reproductive cycles, your mood fluctuations, even the rate at which your cells divide. All of these emerged from organisms that spent billions of years learning to dance with the sun and moon. The neuroscientist Matthew Walker, in his 2017 book, Why We Sleep, revealed something fascinating. Humans are the only species that deliberately deprive themselves of sleep. Every other animal on Earth surrenders to their circadian rhythm without resistance. Birds don't lie awake worrying. Dolphins don't scroll through their phones. They trust the rhythm. They remember what we've forgotten. That sleep isn't something you do. It's something you allow. And here's the first mind-blown moment of tonight. When you resist sleep, you're not just fighting your tired eyes. You're fighting 4.6 billion years of cosmic choreography. You're trying to hold yourself apart from a dance that involves the moon, the sun, the rotation of the Earth, and the gravitational influence of every planet in the solar system. No wonder it's exhausting. But what if you stopped fighting? What if, instead of trying to fall asleep, you simply acknowledge that you're already part of this ancient rhythm? That's what we're going to explore. Because the solar system has secrets that will make sleep feel less like a loss of consciousness and more like coming home. Let me tell you about the sun's heartbeat. The sun isn't a constant, unchanging ball of fire. It breathes. Right now, at this exact moment, the sun's surface is rising and falling like a chest, taking slow, deep breaths. These oscillations, discovered by astronomer Edward Rhodes in 1977, occur in precise 5-minute intervals. The entire visible surface of the sun rises by about 15 kilometers, then falls, then rises again, in an eternal rhythm that's been going on for billions of years. Think of it like this. Imagine the sun as an enormous bell that's been struck once 4.6 billion years ago. It's still ringing. Those 5-minute oscillations are the sun's ringing, echoing through space, creating subtle pressure waves that wash over Earth like the gentlest ocean tide. But here's what will blow your mind. Scientists have discovered that the sun doesn't just oscillate in one pattern. It oscillates in millions of different patterns simultaneously. Different layers of the sun vibrate at different frequencies, creating what helioseismologist Jürgen Christensen Dalsgaard calls a cosmic symphony. In 1996, he and his team used these oscillations to map the interior of the sun, essentially listening to it like a doctor listens to a heartbeat. What they found was astonishing. The sun has layers, each vibrating at its own frequency, each contributing a different note to the solar symphony. The core vibrates differently than the radiative zone. The convective zone has its own rhythm. And the surface, the photosphere, plays the melody we can actually observe. These aren't random vibrations. They're harmonics, mathematical relationships between frequencies that create consonance rather than dissonance. The same mathematical principles that make a piano chord sound pleasing to your ear are operating inside the sun. The universe, it turns out, prefers harmony over chaos. And here's the connection to sleep that nobody talks about. These solar oscillations affect Earth's magnetic field in subtle but measurable ways. The solar wind, a stream of charged particles flowing from the sun, carries the rhythm of these oscillations. When it interacts with Earth's magnetosphere, it creates what are called geomagnetic micropulsations, tiny fluctuations in the magnetic field that occur at frequencies between 0.001 and 1 Hertz. These frequencies are in the same range as human brainwave patterns during deep sleep. Delta waves, the slowest brainwave pattern associated with dreamless sleep, occur at 0.5 to 4 Hertz. The physicist Michael Persinger spent decades studying how these natural electromagnetic fields affect human consciousness, and while his conclusions were controversial, the basic observation was undeniable. Human brains are exquisitely sensitive to the exact frequencies that the Sun-Earth system naturally produces. You are literally bathed in a magnetic lullaby every single night. The sun pulses, Earth's magnetic field responds, and your brain synchronizes with the rhythm. This isn't mysticism. This is physics, but the sun's influence goes deeper. Every 11 years, the sun's magnetic field completely flips. North becomes south. South becomes north. This is called the solar cycle, first noticed by amateur astronomer Heinrich Schwab in 1843 after 17 years of daily observations. He noticed that the number of sunspots increased and decreased in a regular pattern. During solar maximum, when sunspot activity is highest, the sun is more energetic, more active, more restless. During solar minimum, it's calmer, quieter, more peaceful. And while the effect on Earth is subtle, it's measurable. Studies have shown correlations between solar activity and everything from aurora frequency to tree ring growth to, yes, human sleep patterns. We're currently approaching a solar maximum, expected to peak in 2025. But here's the reassuring part. We've been through thousands of these cycles. Your ancestors slept through all of them. The cosmic rhythm continues regardless, and sleep remains possible, remains natural, remains inevitable. Let me share something that might help you tonight. When you close your eyes, remember that you're not alone in the dark. 150 million kilometers away, the sun is breathing. 5 minutes up, 5 minutes down. It's been doing this since before Earth had oceans, and it will continue doing it for 5 billion years more. That rhythm is reaching you right now, invisible but real, carried by particles that left the sun's surface 8 minutes ago. You don't have to do anything with this information. Just know it. Let it settle into your awareness like sediment drifting down through still water. The sun is breathing, and so are you, and somewhere in the overlap of those two rhythms, sleep becomes less of a struggle and more of a synchronization. But the sun is just the beginning, because there's another object in our sky whose influence on sleep is so powerful, so undeniable, that every culture in human history has noticed it. And what modern science has discovered about how it works is more beautiful than any myth. Here's a question that sounds simple, but isn't. Why do we have a moon? Not in the sense of how it formed, we'll get to that, but why does a planet our size have a satellite so disproportionately large? Earth's moon is the 5th largest moon in the solar system, but Earth is only the 5th largest planet. Most planets our size have either tiny moons or no moons at all. Mars, slightly smaller than Earth, has 2 moons that are basically captured asteroids, each just a few kilometers across. Venus, nearly identical to Earth in size, has no moon at all. But our moon is more than a quarter of Earth's diameter. In the entire solar system, only Pluto has a larger moon relative to its planet size, and Pluto is barely bigger than our moon to begin with. This is so unusual that for decades, scientists called it the lunar formation problem. And the solution, when we finally figured it out, turned out to be one of the most violent and beautiful origin stories in the solar system. About 4.5 billion years ago, when Earth was only 100 million years old, another planet smashed into it. This planet, which scientists have named Theia after the Greek titan who gave birth to the moon goddess Selene, was roughly the size of Mars. The impact vaporized Theia, liquefied Earth's surface, and sent billions of tons of debris spinning into orbit. Over the next few thousand years, that debris coalesced into the moon. The planetary scientist Robin Knopp ran computer simulations of this impact in 2001, and what she found was remarkable. The collision had to occur at exactly the right angle, at exactly the right speed, with both planets having exactly the right composition for the result to be a stable Earth-Moon system. Any variation, and either the debris would have fallen back to Earth, or it would have escaped into space entirely. The Moon's existence is the result of a cosmic accident so precisely calibrated that it's almost impossible to believe it was an accident at all. But here's what will blow your mind. That violent collision created the very conditions that made Earth habitable. The impact tilted Earth's axis by 23.5 degrees, giving us seasons. It increased Earth's rotational speed, shortening the day. And it gave us a moon massive enough to stabilize Earth's axial tilt over billions of years, preventing the wild climate swings that would have made complex life impossible. Think of it like this. The moon is the universe's way of apologizing for almost destroying Earth. The catastrophe that nearly ended our planet before it began instead created the precise conditions necessary for someone billions of years later to lie in bed thinking about it. But the moon's greatest gift to Earth wasn't geological stability. It was rhythm. When the moon first formed, it was about 15 times closer to Earth than it is now. Tides weren't measured in meters. They were measured in kilometers. Waves the size of mountains swept across the young Earth twice a day as the moon's gravity pulled at the oceans with tremendous force. The day was only about 5 hours long. Everything was faster, more violent, more intense. But friction between Earth's oceans and the moon's gravitational pull gradually transferred angular momentum from Earth to the moon. Earth's rotation slowed. The moon drifted farther away. The tides became gentler. And over 4.5 billion years, the system settled into something so mathematically perfect that we take it for granted: tidal locking. The moon is tidally locked to Earth, meaning it always shows us the same face. Its rotation period exactly matches its orbital period, 27.3 days. This didn't happen by chance. It happened because Earth's tidal forces gradually slowed the moon's rotation until it reached this stable configuration. And here's the thing. Earth is slowly becoming tidally locked to the moon, too. In about 50 billion years, if the sun doesn't engulf us first, Earth's day will equal the moon's orbital period, and the moon will hang motionless in the sky above one hemisphere, invisible from the other. But right now, we exist in the beautiful middle ground. The moon still pulls at us with enough force to create tides, but gently. Earth still rotates faster than the moon orbits, but not by much. And the result is a rhythm that every living thing on Earth has evolved to recognize and respond to. Marine biologist Ernest Naylor spent his career studying how ocean creatures respond to tidal cycles. In a famous 1985 experiment, he brought shore crabs into a laboratory with no external time cues, no light, no temperature changes, no sound. Yet the crabs continued to follow a precise tidal rhythm, becoming active when high tide would have occurred on their home beach, even though they were hundreds of kilometers away in a tank. The rhythm was in them. The moon had written its schedule into their biology. Humans have the same rhythms, though we've learned to ignore them. The 29.5-day lunar cycle matches the average human menstrual cycle so closely that, for most of history, people assumed there was a direct causal link. Modern research is more nuanced, but the correlation remains. Studies have shown that people tend to sleep less during full moons, even when they don't know the phase of the moon. Hospital records show slight upticks in emergency room visits during full moons. Police departments have documented increased activity. The scientific consensus is that these effects are real but subtle, and the mechanism isn't mystical, it's luminous. Even through closed curtains, even through closed eyelids, your brain can detect the increased ambient light of a full moon. And light, as we now know, is the most powerful regulator of human circadian rhythms. But here's the second mind-blown moment. The moon isn't just affecting you through light. It's affecting you through gravity. Right now, at this exact moment, the moon's gravitational pull is creating a tide in your body. It's incredibly small. Your body isn't mostly water in the sense that oceans are mostly water. Your water is bound up in cells, not free-flowing. But the effect is measurable. The moon is pulling at you with the same force it uses to pull at the oceans, just with less dramatic results. When you lie down to sleep, you're aligning yourself with Earth's surface, minimizing the gravitational gradient across your body. You're making yourself as uniform as possible in the gravitational field. And there's something deeply restful about that, about becoming, for a few hours, just another feature of the landscape, no more vertical or special than a hill or a valley. The moon makes this possible. Without the moon, Earth would wobble chaotically on its axis. Seasons would be unpredictable. Climate would be unstable. The steady rhythm we rely on for sleep wouldn't exist. We owe our circadian stability to a catastrophic collision that happened 4.5 billion years ago. Tonight, when you close your eyes, take a moment to acknowledge the moon. You don't need to see it. It's there, pulling at you with the gentlest insistence, the same way it's been pulling at Earth for longer than there have been eyes to see it. Let yourself be pulled. Let yourself drift toward sleep the way the tides drift toward shore. You've been doing it your whole life. The moon is still teaching you how. But we're only beginning to understand the solar system's lullaby. Because there's another force at work, one that operates on a scale so vast it's almost impossible to comprehend, yet so gentle you've never noticed it. Let me tell you about the rhythm of planets. Imagine a grandfather clock. The pendulum swings back and forth in a precise rhythm. Now imagine two grandfather clocks standing next to each other. Over time, their pendulums will synchronize. They'll start swinging in harmony, not because they're mechanically connected, but because the vibrations of one clock travel through the floor and subtly influence the other. This phenomenon is called mechanical resonance, and Dutch physicist Christian Huygens first documented it in 1665 when he noticed two pendulum clocks mounted on the same wall synchronizing themselves. Now scale that up to planetary size. Replace the clocks with worlds. Replace the floor with gravitational fields stretching across hundreds of millions of kilometers. And you get orbital resonances, one of the most beautiful phenomena in the solar system. Here's an example that will blow your mind. For every 2 times Jupiter completes an orbit around the Sun, Saturn completes almost exactly 5 orbits. The ratio isn't perfect. It's 2.49 to 1 rather than exactly 2.5 to 1. But it's close enough that the two planets experience a near resonance. Every 900 years or so, Jupiter and Saturn align in the sky, creating what's called a great conjunction. The last one occurred in December 2020. The next will occur in 2080. But here's what makes this truly remarkable. This near resonance isn't stable. Over millions of years, Jupiter and Saturn's orbits are very slowly drifting apart. Computer simulations run by astronomer Jacques Lasker in 2009 showed that the solar system is actually slightly chaotic. Not wildly unstable. Earth isn't going to crash into Venus next Tuesday, but unpredictable over timescales of millions of years. Yet despite this chaos, despite the slow drift, the solar system has maintained approximate resonances for billions of years. Why? Because resonances are stable. When planets fall into resonance, they tend to stay there. Their mutual gravitational influences reinforce the pattern rather than disrupting it. Think of it like this. Imagine you're pushing a child on a swing. If you push randomly, sometimes the swing goes higher, sometimes lower. But if you push in rhythm with the swing's natural frequency, every push reinforces the motion. That's resonance. The planets are pushing each other in rhythm, and the rhythm is so stable that it's been going on for longer than Earth has had continents. The most perfect example is Jupiter's moons. In 1610, Galileo Galilei discovered 4 moons orbiting Jupiter: Io, Europa, Ganymede, and Callisto. These were the first objects ever confirmed orbit something other than Earth, and their discovery shattered the geocentric model of the universe. But Galileo didn't live long enough to discover the real magic. 3 of those moons, Io, Europa, and Ganymede, are locked in a perfect 1 to 2 to 4 orbital resonance. For every 1 orbit, Ganymede completes around Jupiter, Europa completes exactly 2, and Io completes exactly 4. This pattern is so precise that if you know the position of one moon, You can calculate the positions of the other two with extraordinary accuracy. Planetary scientist Peter Goldreich proved in 1965 that this resonance is self-maintaining. The tidal forces between the moons and Jupiter create friction, and that friction generates heat. But the resonance ensures that this energy is distributed evenly. The system can't break apart because any deviation from the resonance is automatically corrected by the gravitational interactions between the moons. The result? Io, the innermost moon, is the most volcanically active body in the solar system. Its surface is constantly being resurfaced by sulfur eruptions. Europa, the next moon out, has an ocean beneath its icy surface that might contain more water than all of Earth's oceans combined. And Ganymede, the largest moon in the solar system, has its own magnetic field. All of this geological activity, all of this potential for life, exists because 3 moons learned to dance in perfect harmony billions of years ago. But here's what nobody tells you. Earth is part of these dances too. We think of ourselves as isolated, but we're not. Earth's orbit is influenced by Jupiter. Jupiter's massive gravity tugs at us every time it passes relatively close. The effect is tiny. Jupiter will never pull Earth out of orbit, but over millions of years, these tiny tugs add up. Astrophysicist Milutin Milankovic discovered in the 1920s that Earth's orbit isn't perfectly circular. It oscillates between slightly more circular and slightly more elliptical over a cycle of about 100,000 years. This is partly due to Jupiter's gravitational influence. Earth's axial tilt also oscillates, varying between 22.1 and 24.5 degrees over a 41,000-year cycle. And Earth's axis wobbles like a spinning top, completing one full wobble every 26,000 years. These 3 cycles, orbital eccentricity, axial tilt, and axial precession, combine to create what are now called Milankovic cycles. And here's the mind-blowing part. These cycles control Earth's ice ages. When Earth's orbit is more elliptical, when its tilt is smaller, when the northern hemisphere summer occurs while Earth is farther from the sun, ice ages begin. When the opposite conditions align, ice ages end. The last ice age ended about 11,700 years ago. We're currently in an interglacial period, a relatively warm phase. But in about 50,000 years, the cycles will align again, and glaciers will advance across the continents once more. This isn't speculation. This is orbital mechanics. Jupiter and the other planets are steering Earth's climate on timescales longer than human civilization. Think of it like this. You're not just sleeping on a planet. You're sleeping on a world whose climate, whose seasons, whose very habitability is determined by a cosmic dance involving every major planet in the solar system. The warmth of your bed exists because right now, Earth happens to be in the warm phase of a cycle controlled by gravitational forces stretching from here to Neptune. And here's the third mind-blown moment of the night. You can't fall out of this dance. You can't opt out. The planets are going to continue their gravitational choreography, whether you're awake or asleep, whether you're anxious or peaceful, whether you're paying attention or not. The solar system doesn't need your permission to continue. It doesn't need your participation. It's going to carry you through space at 828,000 kilometers per hour, regardless of how you feel about it. So why fight it? Why resist sleep when sleep is just another way of surrendering to forces that have been guiding Earth for billions of years? The same gravitational resonances that keep Jupiter's moons in perfect harmony are keeping Earth in the habitable zone. The same cosmic rhythms that create ice ages also create the stable climate that allowed your species to evolve in the first place. When you close your eyes tonight, remember, you're not falling into unconsciousness. You're synchronizing with the solar system. You're letting your small personal rhythm merge with the vast, impersonal rhythms that govern planets. And there's something profoundly restful about that, about being a small note in a very large symphony. But we haven't even gotten to the strangest part yet. Because there's something in our solar system so alien, so fundamentally different from anything else, that just thinking about it can shift your consciousness into a more relaxed state. Let me tell you about the rings of Saturn. If you could somehow stand on one of Saturn's rings, which you can't, because they're made of billions of individual ice particles, each on its own independent orbit, but if you could, you would see something that has no analog in human experience. You would see a horizon of ice stretching in every direction, billions of kilometers of frozen water particles, each one catching sunlight and reflecting it back into space, creating a band of light so bright that it illuminates Saturn's night side. But here's what would really break your brain. Those ice particles aren't touching each other. The rings look solid from a distance, but they're not. They're more like a very dense cloud than a structure. Each particle is on its own elliptical orbit around Saturn, moving at its own speed, occasionally colliding with neighbors, but mostly just drifting in formation like birds in a flock. And despite this apparent chaos, the rings maintain precise, mathematically perfect divisions. The Cassini division, discovered by Giovanni Cassini in 1675, is a 4,800-kilometer wide gap between Saturn's two largest rings. For centuries, nobody understood why this gap existed. Then in the 1860s, mathematician James Clerk Maxwell proved that Saturn's rings couldn't be solid. They had to be composed of many small particles. And physicist Daniel Kirkwood showed that the Cassini division exists because particles in that region are in a 2-to-1 orbital resonance with Saturn's moon Nemesis. Think of it like this. Any ice particle in the Cassini division completes exactly 2 orbits around Saturn for every 1 orbit Nemesis completes. This means that every other orbit, the particle experiences a gravitational tug from Nemesis at exactly the same point in its orbit. Over time, these repeated tugs pull particles out of that region, maintaining the gap. The rings are full of these gaps and divisions, each one corresponding to a resonance with one of Saturn's many moons. The rings aren't random. They're organized by the same mathematical principles that organize Jupiter's moons, that create Earth's ice ages, that make the sun oscillate. The universe, it turns out, really prefers integer ratios. But here's what will blow your mind. Saturn's rings are young, astronomically young. When the Cassini spacecraft measured their mass in 2017, scientists were shocked to discover that the rings probably formed less than 100 million years ago, maybe as recently as 10 million years ago. This is astounding because Saturn itself is 4.5 billion years old. For 99% of Saturn's existence, it didn't have rings. Planetary scientist Robin Knopp's current hypothesis is that the rings formed when a moon ventured too close to Saturn and was torn apart by tidal forces. The moon broke into pieces, and those pieces broke into smaller pieces, and eventually the entire moon became a disk of orbiting debris. We're seeing Saturn's rings during a brief cosmic moment when they happen to exist. In another 100 million years, they'll probably be gone, fallen into Saturn's atmosphere, or scattered into space. This should be sad, but somehow it isn't. There's something deeply peaceful about the impermanence of it. The most beautiful structure in the solar system, the image that appears on posters and screensavers and textbooks, is temporary. It won't last, but right now, in this moment, it exists. And maybe that's enough. The astronomer Carl Sagan, who spent his career studying the solar system, once said something beautiful about the rings. He said they reminded him of the impermanence of even the most beautiful things. He said looking at them made him feel a sense of wonder and a sense of responsibility to appreciate beauty while it exists. And here's how this connects to sleep. Sleep is impermanent too. Every night is unique. The exact configuration of your thoughts, your muscles, your neurons firing will never be precisely replicated. You can't step into the same sleep twice, just as you can't step into the same river twice. Each night is its own brief cosmic moment, and then it's gone. But just as Saturn's rings continue to orbit, to catch the light, to inspire wonder, even though they won't last forever, so too does sleep continue to be possible, continue to be restorative, continue to be beautiful, even though each instance of it is fleeting. The Cassini spacecraft, before it plunged into Saturn's atmosphere in 2017, sent back images of the rings that revealed structures nobody had ever seen before. There were braided rings where multiple strands twisted around each other like cosmic rope. There were propeller-shaped gaps created by tiny moonlets embedded in the rings themselves. There were waves, actual density waves, like ripples on a pond, created by the gravitational influence of Saturn's moons. Mission scientist Carolyn Porco, who led Cassini's imaging team, described seeing these images for the first time as like seeing a new world. She said the complexity and beauty of the rings exceeded anything anyone had predicted. The mathematics suggested they should be there, but seeing them, actually observing the universe following its own rules, was transformative. And here's the fourth mind-blown moment. Those images exist now. They're on Earth. You can look at them anytime you want. Humanity has sent a robot to Saturn. The robot orbited for 13 years. It took hundreds of thousands of pictures, and then it dove into Saturn's atmosphere and burned up, its mission complete. And now anyone with an internet connection can see what Cassini saw. You live in a time when the wonders of the solar system aren't mysterious. They're documented. You don't have to wonder what Saturn's rings look like up close. You can see them. You can see the gaps, the waves, the braids. You can watch time-lapse videos of the rings rotating. You can calculate their mass, their composition, their age, their eventual fate. This should make them less mysterious, but it doesn't. If anything, knowing more about the rings makes them more awe-inspiring, because now you understand that what looks like a solid structure is actually billions of independent orbits. What looks eternal is actually temporary. What looks simple is actually governed by mathematics so complex that it took centuries to figure out. When you close your eyes tonight, imagine Saturn's rings. Not the cartoon version, the real version. Billions of ice particles, each one on its own elliptical path, each one reflecting sunlight, each one responding to gravitational tugs from dozens of moons, all of them together, creating a structure so beautiful that it takes your breath away. And then imagine this. Those particles aren't trying to be beautiful. They're not trying to organize themselves into rings. They're just following the laws of physics, just responding to gravity, just existing. And somehow, without intention, without effort, beauty emerges. That's what sleep is. You don't have to try to make it beautiful or peaceful or restorative. You just have to follow your nature, respond to your biology, exist. And somehow, without intention, without effort, rest emerges. But the solar system has more to teach us. Because there's a planet in our cosmic neighborhood that spent billions of years creating the most elaborate sleep environment imaginable, and then abandoned it. Let me tell you about Mars. Close your eyes and imagine a river. Not a raging torrent, but a gentle flow. Water moving across red sand, carving channels, depositing sediment, creating deltas where it empties into calm seas. Now imagine that river has been dry for 3 billion years, but the channel is still there. You can still see exactly where the water went. The stones are still rounded from tumbling. The banks are still defined. Everything about it says, water was here, except the water itself. That's Mars. The entire planet is a fossil of water. The geologist Michael Carr spent decades studying Martian surface features, and in 1996, he published a comprehensive catalog of what he called valley networks, branching channels that looked exactly like river systems on Earth, thousands of them, covering the ancient Martian highlands, each one telling the same story. Mars had water, lots of water, flowing water, for millions, possibly billions of years. But here's what makes this profound. Mars didn't just have water. It had a water cycle. Clouds formed. Rain fell. Rivers flowed. Lakes filled. Water evaporated, and the cycle continued. For this to work, Mars needed an atmosphere thick enough to allow liquid water to exist. It needed temperatures warm enough to prevent everything from freezing. It needed a magnetic field strong enough to protect that atmosphere from being stripped away by solar wind. Mars had all of these things. And then it lost them. About 3.7 billion years ago, Mars's liquid iron core solidified. Without a churning liquid core, Mars couldn't generate a magnetic field. Without a magnetic field, the solar wind began stripping away its atmosphere. Without a thick atmosphere, temperatures dropped and pressure decreased. Liquid water became impossible. The rivers evaporated. The lakes froze, then sublimated directly into space. Over hundreds of millions of years, Mars transformed from a world of water into a frozen desert. But here's the thing that will change how you think about sleep. The water didn't completely disappear. It's still there, under the surface, frozen in polar ice caps, locked in minerals. The Mars Reconnaissance Orbiter, using ground-penetrating radar, has mapped massive deposits of subsurface ice. Some estimates suggest Mars has enough frozen water that if it all melted, it would cover the planet in an ocean 35 meters deep. Think of it like this. Mars is sleeping. It still has water, but the water is dormant. It still has the capacity for rivers and rain, and maybe even life, but that capacity is frozen, waiting. Mars isn't dead, it's dormant. And there's something deeply peaceful about that distinction. The geologist Natalie Cabral studies ancient lake beds on Mars, and she's made a fascinating observation. Even after the lakes dried up, even after the water disappeared, the minerals left behind created environments that could have preserved microbial life for billions of years. She found similar environments on Earth, in the Atacama Desert in Chile, where microbes survive in salt deposits, waiting for the rare rain. This is called cryptobiosis, hidden life. Organisms that can shut down their metabolism almost completely, survive in a state that's neither alive nor dead, and then reactivate when conditions improve. Tardigrades do this. Certain bacteria do this. Seeds do this. And maybe, just maybe, ancient Martian life did this too. We don't know yet. We haven't found it. But the Mars Perseverance rover, which landed in 2020, is currently collecting rock samples that will eventually be returned to Earth for analysis. In those rocks might be evidence of organisms that shut themselves down when Mars lost its water. Organisms that are still waiting, 3 billion years later, for the planet to wake up. Here's the fifth mind-blown moment. If Martian life exists in cryptobiosis, it's been asleep longer than complex life has existed on Earth. It went dormant before Earth had oxygen in its atmosphere. It entered a state of suspended animation before the first animals evolved. And it's still waiting. This makes human sleep look laughably brief. You think 8 hours is a long time? Mars is teaching us that sleep can last for eons. That dormancy isn't failure. That waiting isn't the same as dying. And there's something profoundly restful about that perspective. Because humans fear sleep. Not consciously, usually, but at some deep level, sleep feels like loss of control. It feels like surrender. It feels like a little death. We resist it even when we're exhausted, because some part of us worries that if we let go, we might not come back. But Mars teaches us that dormancy is reversible. That frozen doesn't mean dead. That systems can shut down completely and still retain the capacity to reactivate. Your body knows this. It does this every night. Your metabolism slows. Your temperature drops. Your consciousness dims. And then, automatically, without your intervention, everything reverses. You wake up. The system reboots. This isn't magic. This is biology. And biology learned how to do this from chemistry. And chemistry learned it from physics. And physics learned it from the fundamental laws of the universe that govern everything from the water cycle on Ancient Mars to the sleep cycle in your brain. The neuroscientist Michel Jouvet discovered in the 1950s that sleep isn't passive. It's not simply the absence of wakefulness. It's an active process controlled by specific brain regions. Your brain isn't shutting down when you sleep. It's changing modes. It's shifting from external processing to internal processing. It's running maintenance routines, consolidating memories, clearing out metabolic waste. And here's the connection to Mars. Just as Mars went dormant but preserved its water, your brain goes dormant but preserves your memories. Just as Mars can theoretically reactivate if conditions change, your brain reactivates every morning. The cycle is different in scale, but identical in principle. Dormancy, preservation, reactivation, repeat. When you close your eyes tonight, remember Mars. Remember that dormancy is ancient. That water has been cycling between liquid and solid for billions of years. That the same molecules that flowed in Martian rivers 4 billion years ago are still there, still capable of flowing again, just waiting for conditions to change. You're not losing anything when you sleep. You're preserving it. You're entering a state that life has been perfecting for billions of years. A state so reliable that organisms trust it with their continued existence. A state so fundamental that it operates on scales from bacteria to planets. But there's an even stranger lesson waiting for us, and it comes from the darkest, coldest, most distant places in the solar system. Let me tell you about the outer darkness. Neptune is so far from the sun that sunlight takes more than 4 hours to reach it. When you look at Neptune through a telescope, you're seeing sunlight that left the sun's surface 4 hours ago, bounced off Neptune's blue clouds, and traveled another 4 hours back to Earth. You're seeing the planet as it was 8 hours ago. But here's what makes Neptune extraordinary. Despite being 4.5 billion kilometers from the sun, despite receiving less than 1% of the sunlight Earth receives, Neptune has weather. Active, violent weather. Storms larger than Earth that rage for years. Winds exceeding 2,000 kilometers per hour, the fastest in the solar system. Cloud formations that appear and disappear on timescales of weeks. This shouldn't be possible. Weather requires energy. On Earth, weather is driven by solar heat, creating temperature differences that drive wind and rain. But Neptune barely receives any solar heat. So where is all that energy coming from? The answer, discovered by the Voyager 2 spacecraft when it flew past Neptune in 1989, is that Neptune is generating its own heat. The planet emits more than twice as much energy as it receives from the sun. Deep in Neptune's interior, something is creating warmth. Most likely it's residual heat from the planet's formation, still radiating outward after 4.5 billion years, combined with helium rain in the atmosphere, releasing gravitational potential energy as heat. Think of it like this. Neptune is lit from within. In the cold darkness at the edge of the solar system, this distant world maintains its own warmth, creates its own weather, persists despite receiving almost no energy from the sun. There's a lesson here about sleep that nobody talks about. We think of sleep as something that happens to us, something external, something we need ideal conditions for. The room has to be the right temperature. The bed has to be comfortable. The environment has to be quiet. We treat sleep as fragile, as though it requires perfect circumstances to occur. But that's not what sleep is. Sleep is endogenous. It comes from within. Your body generates the biochemical conditions for sleep, regardless of what's happening around you. The suprachiasmatic nucleus in your hypothalamus tracks time even in complete darkness. Your pineal gland produces melatonin, whether you're in a comfortable bed or a prison cell. Your sleep drive accumulates with every hour you stay awake, building pressure that eventually becomes irresistible. You are like Neptune. You generate your own warmth. You create your own internal weather. You don't need ideal external conditions, because the machinery that produces sleep is inside you, has always been inside you, will always be inside you. The astronomer Heidi Hammel, who has studied Neptune for decades, once said something beautiful about it. She said that discovering Neptune generates its own heat changed how I think about planetary persistence. She said it showed her that worlds can maintain themselves in environments that seem hostile to their existence. You are a world maintaining yourself in an environment that often seems hostile to sleep. The modern world is bright when it should be dark, stimulating when it should be calm, demanding when it should be restful, and yet you still sleep. Because the drive to sleep isn't dependent on external perfection. It's generated by internal processes that predate human civilization, that predate humanity, that predate multicellular life. But Neptune has more to teach us. Because Neptune has a moon, Triton, that is one of the strangest objects in the solar system. Triton orbits Neptune backward. Every other major moon in the solar system orbits in the same direction its planet rotates. But Triton orbits in the opposite direction. This is called a retrograde orbit, and it tells us something important. Triton wasn't formed alongside Neptune. It was captured. Billions of years ago, Triton was probably a dwarf planet like Pluto, independently orbiting the Sun. Then it ventured too close to Neptune, and Neptune's gravity captured it. The capture would have been violent. Triton's orbit would have been highly elliptical at first. It would have swung close to Neptune, then far away, then close again. The tidal forces would have been tremendous. But over hundreds of millions of years, those tidal forces circularized Triton's orbit. They dissipated its orbital energy as heat, gradually pulling it into a more stable configuration. Today, Triton's orbit is nearly perfectly circular. It's still retrograde, it still orbits backward, but it's stable. It's found peace in a configuration that initially seemed catastrophic. And here's the sixth mind-blown moment. Triton is still generating heat from this process. When Voyager 2 flew past in 1989, it photographed geysers erupting from Triton's surface, jets of nitrogen gas shooting 8 kilometers into space. On a moon with a surface temperature of -235 degrees Celsius, active geology. Because the tidal heating from that ancient capture is still working through Triton's interior, still warming it, still making it active. Think of it like this. Trauma can become heat. Disruption can become energy. A catastrophic event billions of years ago is still providing warmth today, not as destruction, but as geology, as activity, as proof that the moon persists. When you can't sleep, when your thoughts are racing, when the day's disruptions keep replaying in your mind, remember Triton. Remember that your nervous system is processing those events, dissipating their energy, gradually pulling you toward equilibrium. The process isn't instantaneous. It takes time. But it's happening whether you're aware of it or not. Your body knows how to metabolize stress. It's been doing it for billions of years. Every cell in your body is descended from cells that survived catastrophes that make your bad day look insignificant. Mass extinctions, ice ages, supervolcano eruptions, and yet here you are. Because life knows how to process disruption, how to convert chaos into stability, how to orbit backward if necessary, but eventually find a circular path. The psychiatrist Bessel van der Kolk, who studies trauma, has written extensively about how the body processes disturbing experiences during sleep. REM sleep, the phase where you dream, is when your brain replays difficult memories in a safe context, gradually reducing their emotional intensity. It's like Triton's orbits circularizing. The same event, repeated over and over, but each time with less violence, less disruption, less heat, until finally it's just another memory, just another part of your history, no longer actively disturbing you. This is why sleep is so important after difficult days. Not because it makes you forget, because it helps you process. It helps you metabolize. It helps you take the elliptical, chaotic orbit of fresh trauma and gradually, night by night, pull it into something more circular, more stable, more livable. When you close your eyes tonight, whether you've had a good day or a terrible one, remember that your brain knows what to do. It's going to replay events. It's going to process emotions. It's going to gradually dissipate the energy of the day as neural activity, as dreams, as the gentle tidal heating of your nervous system finding equilibrium. You don't have to manage this process. You just have to allow it. Just like Triton didn't have to consciously circularize its orbit. The laws of physics did it automatically. Just like Neptune doesn't have to consciously generate heat. It happens as a consequence of fundamental processes. And just like your sleep doesn't require your conscious management. It emerges from systems far older and wiser than your conscious mind. But we're approaching something now. Something personal. Because all of these cosmic phenomena, all of these distant worlds and ancient rhythms, are about to connect to your life in a way that might fundamentally change how you see yourself. Are you ready? Every atom in your body except hydrogen was created inside a star. This isn't a metaphor. This is physics. The carbon in your cells, the iron in your blood, the calcium in your bones, all of it was forged in stellar cores at temperatures exceeding 10 million degrees Celsius, then scattered across space when those stars exploded as supernova. The astronomer Carl Sagan famously said, "We are made of star stuff." But here's what he didn't emphasize enough. We are made of dead star stuff. We're not made from stars that are still shining. We're made from stars that died, that exploded, that ceased to exist as coherent objects billions of years ago. Your body is a memorial to stellar death. But here's what will blow your mind. Those stellar deaths were necessary. A living star holds its atoms in plasma, at temperatures where complex chemistry is impossible. Only when the star dies, only when it explodes and scatters its atoms into cold space, can those atoms cool enough to form molecules. Only in the darkness between stars can atoms bond into water, into amino acids, into DNA, into you. Life requires death, not as a poetic metaphor, as a thermodynamic necessity. The astrophysicist Enrico Fermi calculated in the 1950s that every cubic centimeter of your body contains atoms from approximately 10 different stellar sources. You're not made from one star. You're a mosaic of multiple stellar deaths, each one contributing different elements, each one with its own history. The oxygen you're breathing right now was created in a star that died at least 4.6 billion years ago, before the sun even formed. That star lived for perhaps 10 million years, then exploded. Its oxygen atoms drifted through space for hundreds of millions of years, before being incorporated into the molecular cloud that collapsed to form the sun and planets. Those atoms became part of Earth, then ocean, then atmosphere, then a plant, then the air, then your lungs, and now they're in your bloodstream, binding to hemoglobin, being transported to your cells, where they'll participate in cellular respiration for a few minutes before being exhaled back into the atmosphere. Those atoms have been on a journey that spans billions of years and multiple lives as stars, clouds, planets, and organisms. And right now, they're part of you. Temporarily. Think of it like this. You don't own your atoms. You're borrowing them. Every atom in your body will eventually be part of something else. The carbon that's currently in your neurons might end up in a tree in 100 years. The iron in your blood might end up in ocean sediment. The calcium in your bones might end up in a seashell. You are a temporary configuration of matter that once was stars and will someday be something else. Between those states, you exist. And sleep is the nightly reminder of this impermanence. When you lose consciousness, when your sense of self dissolves into sleep, you're experiencing a preview of what it's like to be matter without consciousness. For 8 hours, your atoms continue their chemical reactions. But you, the emergent pattern of thoughts and memories and identity, disappears. And then, every morning, that pattern reconstitutes itself. You wake up. The atoms haven't changed much, but the organization of those atoms has cycled through states of consciousness and unconsciousness. The neuroscientist Giulio Tononi has a theory about this called integrated information theory. He proposes that consciousness is a property of systems that integrate information in specific ways. During deep sleep, your brain's information integration decreases. Networks become isolated. the unified sense of self-fragments. You still exist as a physical system, but the emergent property we call consciousness fades. And then it comes back. Every morning, automatically, here's the seventh mind-blown moment. You've already experienced what death might be like. Every time you fall into dreamless sleep, you cease to be conscious. There's a period of time where, from your subjective experience, you don't exist. And yet, you're never afraid during that period, because you're not there to be afraid. And then you come back. This should make death less terrifying, though it usually doesn't. But it should also make sleep less terrifying, because you've already proven to yourself, thousands of times, that losing consciousness isn't the end, that the pattern can dissolve and reform, that you can be matter without being you, and then be you again. The physicist Alan Lightman wrote beautifully about this in his book, Searching for Stars on an Island in Maine. He said that understanding our atomic heritage made him feel simultaneously insignificant and eternal. Insignificant because any particular configuration of atoms, any individual life, is temporary. Eternal because the atoms themselves persist, cycling through different forms, never created, never destroyed, just rearranged. When you close your eyes tonight, pay attention to the moment of transition, the moment when you're still conscious enough to notice, but relaxed enough to be drifting. That threshold moment. Because that's where you can feel yourself becoming matter again. Not dead matter. Living matter that happens to not be conscious at the moment. Your heart still beats. Your lungs still breathe. Your cells still metabolize. But the organizing principle, the you that thinks and worries and plans, gently releases its grip. This is what every spiritual tradition has been pointing toward with their practices of meditation and mindfulness and surrender. But they often dress it up in mystical language that obscures the physics. Here's the physics. You are a dissipative structure, a pattern maintained by constant flow of energy and matter through a system. When that flow continues, but the pattern relaxes, you get sleep. When the flow stops, you get death. But the atoms? The atoms just continue. They were here before you, and they'll be here after. There's something deeply peaceful about this perspective, because it means you can't really fail at existence. The atoms are going to do their thing regardless. They're going to participate in chemical reactions, follow the laws of thermodynamics, exchange energy, bond, and unbond with other atoms. Whether you're stressed about it or not doesn't change the atomic reality. And sleep is your reminder of this. Every night, you practice not being in control. You practice letting the atomic processes continue without your conscious oversight. And every morning, you wake up to discover that everything kept going. Your heart didn't forget to beat. Your cells didn't forget to metabolize. The solar system didn't forget to continue its gravitational dance. You're not as necessary to your own existence as you think you are. Most of what keeps you alive operates automatically, unconsciously, following rules that were established billions of years before you were born. And that's not a diminishment. That's a relief, because it means you can rest. You can stop trying to manually manage processes that don't require your intervention. You can trust that the atoms that have been cycling through stars and planets and organisms for billions of years know what they're doing. They've had a lot of practice. But there's one more piece to this puzzle. One more way that your cosmic heritage connects to your ability to sleep. And it involves the strangest substance in the universe, the vacuum of space itself. Here's something that will fundamentally alter your understanding of reality. Empty space isn't empty. This isn't philosophy. This is quantum mechanics. The vacuum of space, even in the darkest void between galaxies, where there's no matter, no radiation, nothing, that vacuum seethes with energy. The physicist Werner Heisenberg discovered in 1927 what's now called the uncertainty principle. It states that you cannot simultaneously know a particle's position and momentum with perfect precision. But it also implies something stranger. You cannot have a quantum field with exactly zero energy. There's always a minimum irreducible amount of energy present, even in a vacuum. This is called zero-point energy, and it's everywhere. Right now, in the supposedly empty space between your atoms, quantum fields are fluctuating. Virtual particles are popping into existence, existing for infinitesimally brief moments, then annihilating back into the vacuum. This isn't speculation. The Casimir effect, first measured by Dutch physicist Hendrik Casimir in 1948, proves that zero-point energy has measurable physical consequences. Think of it like this: the universe is never truly at rest. Even at absolute zero temperature, even in perfect vacuum, quantum fields continue to fluctuate. There's a fundamental restlessness to reality at the quantum level. The universe cannot be still. And yet, despite this quantum restlessness, macroscopic objects can be still. You can be still. How? The answer involves something called decoherence. When quantum systems interact with their environment, when they exchange energy and information with surrounding particles, their quantum properties average out. The fluctuations don't disappear, but they become coordinated, synchronized, effectively classical. Your body is constantly interacting with its environment. Photons hitting your skin, air molecules bouncing off you, heat radiating away. Each interaction couples you more tightly to the classical world, suppressing the quantum fluctuations that, at the microscopic scale, are constantly occurring. But here's what makes this relevant to sleep. Your brain operates at the threshold between quantum and classical. Individual neurons are large enough to be classical objects, but the molecular machinery inside them, the ion channels, the neurotransmitter receptors, the synaptic proteins, operate at scales where quantum effects might matter. The physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed, controversially, that quantum coherence in brain microtubules might be involved in consciousness. Most neuroscientists are skeptical, and the theory remains unproven. But even if Penrose and Hameroff are wrong about consciousness, the basic observation stands. Your brain exists at a unique scale where quantum and classical physics overlap. And sleep might be the process that allows your brain to reestablish coherence. During waking hours, your brain is bombarded with sensory information, each input causing decoherence, coupling your neural states to external classical reality. But during sleep, especially deep sleep, sensory input drops dramatically. Your brain becomes more isolated from the environment. And in that isolation, it might be able to reestablish certain quantum correlations that get disrupted during waking. This is highly speculative. I want to be clear about that. We don't have direct evidence that sleep involves quantum processes. But we do know that sleep serves a restorative function at the molecular level, and we know that molecules operate at scales where quantum mechanics matters. Here's the eighth mind-blown moment. You might be quantum entangled with the universe. Not in a mystical sense, but in a physical sense. Every photon that hits your retina, every air molecule that enters your lungs, every gravitational tug from the moon, these create information exchanges that could, in principle, establish quantum correlations between you and your environment. Physicists Leonard Susskind and Juan Maldacena have shown that quantum entanglement and wormholes might be equivalent phenomena, that any two entangled particles are connected by a microscopic wormhole in spacetime. If this is true, then you are connected by actual geometric structures to everything you've ever interacted with. You're not separate from the universe. You're woven into it at the quantum level, connected by invisible threads of entanglement to everything in your light cone, everything that has ever sent you a photon or received one from you. And sleep might be when those connections settle, when the information you've accumulated during the day integrates into the larger pattern, when the local fluctuations of your individual consciousness synchronize with the broader quantum rhythms of the cosmos. I realize this sounds like mysticism. It's not. It's physics. Weird physics, granted. Physics that Einstein himself found so disturbing, he spent decades trying to disprove it. But it's real. Quantum entanglement is real. Zero-point energy is real. The quantum vacuum is real. And if any of this affects consciousness, if any of these quantum processes contribute to what makes you you, then sleep is when those processes reset, recalibrate, reestablish themselves. The neuroscientist Christoph Koch, who has spent decades studying consciousness, wrote something beautiful about this. He said that consciousness is both the most familiar and the most mysterious aspect of our lives. We experience it every waking moment, but we have no idea how it arises from neurons. And we especially have no idea why it turns off during sleep and turns back on during waking. But maybe it doesn't turn off. Maybe it just changes modes. Maybe consciousness during waking is like a radio tuned to one frequency, the frequency of sensory input, of external reality, of classical physics. And consciousness during sleep is like a radio tuned to a different frequency, the frequency of internal processing, of quantum recoherence, of integration with the vacuum fluctuations that underlie all reality. When you close your eyes tonight, remember this. The darkness you see isn't empty. Even with your eyes closed, photons are still interacting with your retinas. Quantum fields are still fluctuating in the space between your neurons. Zero-point energy is still permeating every cubic nanometer of your brain. You're not withdrawing from reality. You're shifting to a different relationship with it. And in that shift, something profound happens. The boundary between you and not you becomes less distinct. Your sense of being a separate entity, isolated from the universe, starts to dissolve. Not completely. You're still you, but the hard edges soften. The quantum entanglements become more apparent. You start to feel, at some level deeper than thought, that you're part of something larger. This is why sleep feels like surrender. Because it is surrender, not to unconsciousness, but to interconnection, to the quantum foam that underlies reality, to the zero-point energy that's been fluctuating since before the Big Bang and will continue fluctuating after the universe grows cold. You can fight this if you want. You can resist sleep, cling to your separate identity, maintain vigilant consciousness. But eventually, you'll lose, because the quantum vacuum is patient. It's been here for 13.8 billion years. It can wait for you to get tired. Or you can surrender now. You can acknowledge that separation is an illusion, that you're already entangled with everything, that sleep isn't losing yourself, but finding yourself in the larger pattern. The choice is yours. But the quantum vacuum will be here either way, fluctuating, seething with energy, connecting everything to everything else in ways we're only beginning to understand. But I need to tell you something that brings this all back to human scale. Back to your life, back to tonight. Because all of this cosmic philosophy means nothing if it doesn't help you actually sleep. So let me tell you how all of this connects to the simple, ordinary, human experience of lying in bed. Your body contains a clock. Not metaphorically, literally. A cluster of about 20,000 neurons in your hypothalamus called the suprachiasmatic nucleus keeps time with remarkable precision. These neurons oscillate with a period of approximately 24 hours, even in complete darkness, even without any external time cues. The discovery of this biological clock won Jeffrey Hall, Michael Rosbash, and Michael Young the Nobel Prize in Physiology or Medicine in 2017. They figured out the molecular mechanism, a group of genes that produce proteins that accumulate during the day, inhibit their own production at night, break down, and then the cycle begins again. It's a genetic feedback loop that creates an oscillation. But here's what makes this extraordinary. This same genetic mechanism exists in nearly every living thing. Fruit flies have it, bread mold has it, algae have it. Even some bacteria have circadian rhythms. This means that biological clocks evolved very early in the history of life, probably more than 2 billion years ago, back when the only living things were single cells. Think of it like this. For 2 billion years, life has been tracking Earth's rotation. For 2 billion years, organisms have been anticipating sunrise and sunset. The rhythm is so ancient, so fundamental, that it's encoded at the genetic level in almost everything alive. You inherited this clock from ancestors who needed to know when to hunt, when to hide, when to sleep. Your neurons are doing exactly what their neurons did. The same genes producing the same proteins in the same feedback loop. You're not just experiencing a circadian rhythm, you're participating in one. You're continuing a biological tradition that stretches back to the Precambrian. But your clock isn't perfect. Left to its own devices, your circadian rhythm runs slightly longer than 24 hours, about 24.2 hours on average. This is why, if you're kept in constant darkness with no time cues, you gradually drift later and later. Your free-running rhythm is slightly slower than Earth's rotation. So how do you stay synchronized? Light. When photons hit the specialized cells in your retina, they send a signal to your suprachiasmatic nucleus that resets the clock. Every morning, sunlight pulls your biological rhythm back into alignment with Earth's rotation. You synchronize with the planet. This is called entrainment, and it's one of the most beautiful examples of how your biology is fundamentally connected to astronomy. You're not separate from Earth's rotation. You're coupled to it. Your genes respond to the sun. Your neurons track the day. You are a clock that winds itself by the same light that has been illuminating Earth for 4.6 billion years. The chronobiologist Charles Chrysler discovered in the 1980s that this synchronization process is incredibly sensitive to blue light, the wavelength most associated with daytime sky. This is why screens disrupt sleep. They emit blue light that your brain interprets as it's still daytime, delaying the clock reset. But here's the ninth mind-blown moment. You can use this. You can deliberately entrain your circadian rhythm. Morning sunlight advances your clock. Evening darkness allows it to run naturally. If you're having trouble sleeping, the solution isn't necessarily better sleep hygiene or relaxation techniques. Sometimes it's just getting outside in the morning and letting photons do what they've been doing for 2 billion years. Your clock wants to synchronize with Earth. That's what it evolved to do. Every genetic circuit, every protein feedback loop, every neural oscillation is designed to track the sun. When you fight this, staying up under artificial light, sleeping in dark rooms during the day, you're not just being stubborn. You're fighting 2 billion years of evolutionary optimization. And here's the thing. You'll lose that fight. Maybe not tonight, maybe not tomorrow, but eventually your biology will win. Your sleep drive will accumulate to the point where it overrides your conscious resistance. Your adenosine levels will build up until staying awake becomes physically impossible. Your circadian clock will assert itself. Sleep isn't optional. It's not a lifestyle choice. It's a biological imperative encoded in your genes by billions of years of evolution under a rotating planet orbiting a star. You can delay it. You can disrupt it. But you cannot eliminate it. And trying to resist it only makes you miserable. The sleep researcher William Dement, who founded the first sleep research center at Stanford, once said, "The brain keeps an accurate account of how much sleep it's owed. If you don't sleep tonight, the debt doesn't disappear. It accumulates. And your brain will collect that debt with interest eventually." But here's the beautiful part. Your brain doesn't want to punish you. It wants to help you. Every neuron in your suprachiasmatic nucleus is working to synchronize you with the natural world. Every protein in your circadian clock is trying to make your sleep predictable, regular, restful. Your biology is on your side. You just have to let it work. You have to stop fighting the clock and start listening to it. And the way you listen is simple. Get bright light in the morning. Dim light in the evening. Maintain regular sleep times. Respect the rhythm that's been running in your cells since before your cells were your cells. When you do this, something remarkable happens. Sleep stops being a struggle. It becomes automatic. Your brain learns to anticipate bedtime. Your melatonin starts rising on schedule. Your body temperature begins dropping at the right time. Your sleep drive builds predictably. And when you lie down, instead of fighting to fall asleep, you simply allow the processes that have been building all day to finally complete themselves. This is what sleep is supposed to feel like, not forced, not fought for, just allowed. Like water flowing downhill, following the path of least resistance, responding to gravity. And speaking of gravity, there's one more force we need to talk about. One more way the solar system is cradling you every night. One more rhythm that's been rocking you to sleep since before you were born. You weigh less at night than you do during the day. Not much less, about 0.5 kilogram on average, but measurably less. This isn't because you're farther from Earth's center at night. It's because the moon's gravity pulls up on you slightly when it's overhead, partially counteracting Earth's pull. This means that twice a day, as the moon passes overhead and then underfoot, your weight oscillates. You get lighter, then heavier, then lighter again. The same tidal forces that create ocean tides create body tides. Your body is literally being pulled into an elliptical shape by the moon, though the deformation is so small, a few millimeters at most, that you'd never notice it. But your inner ear might notice it. The vestibular system, which controls balance, is exquisitely sensitive to gravitational changes. Astronauts in zero gravity experience massive disruption to their vestibular system, leading to nausea and disorientation. But even on Earth, your vestibular system is constantly detecting tiny changes in gravitational force. The moon's tidal pull might be one of those changes. And if your vestibular system is sensitive enough to detect it, then lying down to sleep, horizontally aligning yourself with Earth's surface, minimizing the gravitational gradient across your body, might be, in part, a way of simplifying the gravitational signals your brain has to process. Think of it like this. When you're vertical, gravity pulls harder on your feet than your head. Your heart has to work against gravity to pump blood up to your brain. Your vestibular system has to constantly monitor your orientation. But when you lie down, you become gravitationally uniform. The pull is the same on your head and feet. Your heart can pump more efficiently. Your vestibular system can relax. You're not just resting your muscles when you sleep. You're resting from gravity. But there's a deeper rhythm at work. Earth itself is oscillating. The solid ground beneath you isn't solid at all. Not really. It flexes as the moon passes overhead, rising and falling by about 30 centimeters twice a day. The entire planet breathes with a lunar tidal rhythm. You can't feel this. The change is too slow, too gradual, but it's real. Seismometers measure it. GPS satellites track it. The ground you're lying on right now is either rising or falling, depending on where the moon is in its orbit. And here's the 10th mind-blown moment. This rhythm is slowing down. The moon's tidal pull creates friction between Earth's oceans and the seafloor. That friction dissipates Earth's rotational energy as heat. The result? Earth's rotation is slowing by about 1.7 milliseconds per century. Days are getting longer. When dinosaurs walked the Earth 100 million years ago, a day was only about 23 hours long. When life first emerged 3.5 billion years ago, a day was probably only 8 to 10 hours long. The moon has been gradually slowing Earth's rotation for the entire history of life. This means your ancestors experienced different day lengths. Not just your human ancestors, your pre-human ancestors, your pre-mammal ancestors, your pre-animal ancestors. Every generation has lived through slightly longer days than the generation before. Evolution has been constantly adapting to a gradually changing rotation period. And it's still adapting. Your circadian clock, which runs slightly longer than 24 hours, might be evolution's way of hedging against the gradual lengthening of days. Maybe organisms with clocks that run slightly long have an advantage as Earth's rotation continues to slow. This is speculation, of course. We don't know why circadian clocks run slightly long. But it's a beautiful thought, that the slight mismatch between your internal clock and Earth's rotation might be evolution anticipating the future, preparing you for days that will eventually be longer than they are now. The astrophysicist Neil deGrasse Tyson once calculated that if you could live long enough, you'd eventually experience a day so long that the moon would hang motionless in the sky. Earth would be tidally locked to the moon, the way the moon is already tidally locked to Earth. One side of the planet would always see the moon. The other side would never see it. This won't happen for billions of years. The sun will probably die first. But it's the eventual fate of the Earth-Moon system. The tidal forces that are currently slowing Earth's rotation and pushing the moon farther away will continue until equilibrium is reached. And in the meantime, you get to experience this transition. You live during the epoch when days are 24 hours long, when the moon orbits every 27.3 days, when tides rise and fall predictably. This exact configuration won't last. In the cosmic long term, it's temporary. But right now, it's stable enough that you can set your clock by it. When you close your eyes tonight, feel the weight of your body pressing into the mattress. That pressure, that sensation of being pulled downward, is gravity. The same force that holds the moon in orbit, that creates tides, that has been slowing Earth's rotation for billions of years. You're feeling it right now, directly, personally. And when you lie down, you're surrendering to it. You're acknowledging that you don't have the strength to fight gravity for another 8 hours. Your muscles are tired from holding you upright all day. And there's profound relief in finally letting go, in letting gravity hold you instead of you fighting it. This is the original lullaby, not a melody, not words, just the steady, unwavering pull of mass attracting mass, of Earth's gravity making you feel heavy, of the moon's gravity making you slightly less heavy, of the two forces together creating a rhythm that has cradled every living thing that has ever tried to sleep. You don't need to understand the physics to feel it. You just need to lie down and stop resisting. Let gravity do what gravity does. Let the moon continue its orbit. Let Earth continue its rotation. Let the tidal forces continue their eternal dance. And somewhere in the midst of all that cosmic machinery, you'll find rest. But there's one more piece. One more part of the solar system that connects to your sleep in a way so subtle, so overlooked, that most people never consider it. Let me tell you about the darkness between worlds. Space is dark, profoundly dark. Not the darkness of a room at night, where your eyes eventually adjust and you can make out shapes. Space is dark in a way that's alien to human experience. The darkness between stars is so complete that if you are floating in interstellar space, if you turned away from any nearby stars, you would see nothing. Absolute black. Your eyes would search for something to focus on and find nothing. This terrifies people. When we think about space, we think about the loneliness, the emptiness, the void. But here's what almost nobody thinks about. That darkness is a gift. It's evidence that the universe isn't full of stars in every direction. And if the universe was full of stars in every direction, you wouldn't be here. This is called Olber's paradox, first articulated by astronomer Heinrich Olbers in 1823. He asked, if the universe is infinite and filled uniformly with stars, why is the night sky dark? Shouldn't every line of sight eventually hit a star, making the entire sky as bright as the sun's surface? The resolution is beautiful. The universe isn't infinite in age. It had a beginning. Light from the most distant stars hasn't had time to reach us yet. And the universe is expanding, so light from very distant sources is redshifted into wavelengths we can't see. The night sky is dark because the universe is young enough and dynamic enough that light hasn't had time to fill all of space. Think of it like this. Darkness is evidence of cosmological history. When you look at a dark sky, you're seeing proof that the Big Bang happened, that the universe has an age, that there was a time before stars. Darkness is information. But more than that, darkness is necessary. If space were filled with light, if Earth were bathed in radiation from every direction, life would be impossible. Plants need a light-dark cycle to regulate photosynthesis. Animals need darkness to trigger melatonin production. Ecosystems need the energy gradient between day and night to drive circulation patterns, weather, nutrient cycles. Darkness isn't the absence of something good. Darkness is something good in itself. It's a resource. It's the condition that allows rest, allows recovery, allows biological processes that can't occur under constant light. The ecological dark sky movement has documented how artificial light pollution disrupts everything from insect navigation to bird migration to sea turtle nesting. When we eliminate darkness, we don't just lose the ability to see stars. We disrupt the fundamental rhythms that life evolved under. But here's the 11th mind-blown moment. Earth creates its own darkness. Not just by rotating into shadow, though that's part of it. Earth also has a magnetosphere that shields us from the solar wind, preventing the constant aurora that would otherwise light up the night sky. And Earth has an atmosphere that absorbs most cosmic rays and gamma rays and X-rays that would otherwise create a faint glow. You sleep in a carefully constructed darkness. The planet is actively protecting you from radiation that would prevent sleep. The magnetic field, generated by churning iron in Earth's core, deflects charged particles. The ozone layer, created by ultraviolet light splitting oxygen molecules, absorbs high-energy photons. The atmosphere itself scatters and absorbs incoming radiation. Without these protections, night would be less dark. There would be more airglow, more aurora, more atmospheric luminescence. Sleep would be harder. Maybe impossible. Mars doesn't have this protection. Mars lost its magnetic field billions of years ago, and its atmosphere has been slowly stripped away by the solar wind. The Martian night is darker than Earth's in some ways. No airglow from a thick atmosphere, but also more exposed to cosmic radiation. If you tried to sleep on Mars, you'd be bombarded with particles that your body has no defense against. Earth's darkness is engineered. Not intentionally, there's no engineer, but through billions of years of planetary evolution. The iron core that generates the magnetic field, the atmosphere that generates ozone, the rotation that creates night. All of these features work together to create an environment where darkness is deep enough, regular enough, and safe enough for complex life to evolve circadian rhythms. You are the beneficiary of planetary architecture you never think about. Right now, Earth's magnetic field is deflecting solar wind. Earth's ozone layer is absorbing ultraviolet radiation. Earth's rotation is carrying you into shadow. And all of this is creating the darkness you need to sleep. The poet Rainer Maria Rilke wrote, "I live my life in widening circles that reach out across the world." But he could have written, "I sleep my sleep in darkening circles that the planet creates around me, because that's what's happening." Earth is wrapping you in protective layers of magnetic fields and atmospheric chemistry, creating a pocket of darkness in an otherwise hostile universe. When you close your eyes, you're adding one more layer. Your eyelids block the last remaining photons. And now you exist in nearly complete darkness. Darkness created by Earth's rotation, protected by Earth's magnetic field, made safe by Earth's atmosphere, and completed by your own biology. This darkness connects you to every human who has ever lived. Before electric lights, darkness was unavoidable. For 300,000 years of human history, people experienced true darkness every night. They saw the Milky Way. They navigated by stars. They lived in rhythm with natural light-dark cycles. We've lost that in just 150 years. Electric lights are one of humanity's greatest achievements, but they've come with a cost. We no longer experience the darkness that shaped our evolution. We no longer see the stars that guided our ancestors. We no longer sleep in the same sensory environment that humans slept in for 99.95% of our species' existence. But the biology remains. Your pineal gland still produces melatonin in darkness. Your suprachiasmatic nucleus still responds to light-dark cycles. Your cells still expect 10 to 12 hours of darkness per day. The modern world may have changed, but your ancient biology hasn't caught up. And maybe that's okay. Maybe you don't need to live in complete darkness to sleep well. But maybe, just maybe, acknowledging the darkness, appreciating it, understanding its cosmic significance, can help you surrender to it more easily. When you turn off the lights tonight, you're not just eliminating photons. You're participating in a planetary rhythm. You're allowing Earth's rotation to carry you into shadow. You're trusting billions of years of evolutionary wisdom that says darkness is safe, darkness is restorative, darkness is necessary. The darkness isn't empty. It's full of meaning, full of history, full of the same cosmic background radiation that has been traveling through space since 380,000 years after the Big Bang. The darkness connects you to the origin of the universe, to the death of stars, to the evolution of planets, to the emergence of life. And somewhere in that darkness, you'll find sleep. Not because you're forcing it, because you're allowing the natural rhythms to complete themselves. Because you're surrendering to processes older than continents, older than oceans, older than life itself. But we're almost at the end. And I need to tell you the most important thing. The thing that all of this cosmic knowledge has been building toward. The reason why understanding the solar system can help you sleep. Are you ready? The cosmologist Carl Sagan said, "We are a way for the cosmos to know itself." But I want to take that further. You aren't just a way for the cosmos to know itself. You are the cosmos. There's no separation. The atoms in your body are solar system atoms. The energy in your cells is solar system energy. The rhythms in your brain are solar system rhythms. When you look at the moon, you're not a human looking at a separate object. You're the solar system looking at itself. You're matter that evolved from the same molecular cloud that created the moon. You're stardust that cooled, condensed, assembled into complex molecules, organized into cells, evolved into multicellular life, developed nervous systems, became conscious, and now has the audacity to think of itself as separate from the moon. But you're not separate. You never were. The only difference between you and the moon is complexity and organization. The moon is atoms arranged in a simple way, rock and metal. You are atoms arranged in a fantastically complex way, cells and organs and neural networks. But the atoms? Same atoms. Same solar system. Same origin? The physicist Alan Watts said it beautifully. You are an aperture through which the universe is looking at and exploring itself. When you feel awe looking at the night sky, that's the universe feeling awe at itself. When you wonder about the cosmos, that's the cosmos wondering about itself. When you try to understand your place in the universe, that's the universe trying to understand its own structure. And when you sleep, when you let go of conscious awareness, when you dissolve into dreamless void, that's the universe taking a break from self-observation. It's not that you're disappearing. It's that the particular eddy in the cosmic stream that we call your consciousness is temporarily relaxing, allowing the deeper currents to flow without interference. The mystics have known this for thousands of years. Every spiritual tradition has some version of it. The Hindu concept of Atman Brahman, the individual soul, is identical to the universal soul. The Buddhist concept of dependent origination. Everything arises in relationship to everything else. Nothing exists independently. The Taoist concept of Wu Wei. Effortless action through alignment with the natural flow. But you don't need mysticism to understand this. You need physics. You need to understand that conservation of energy means you're not creating the energy that powers your thoughts. You're channeling it. Conservation of mass means you're not made of special atoms. You're made of recycled star material. And thermodynamics means you're not separate from your environment. You're a dissipative structure maintained by constant exchange with your surroundings. Here's the 12th and final mind-blown moment. You cannot be separate from the solar system because you are a process, not an object. You're not a thing that exists independently. You're a pattern of organization that only exists because of constant input from the sun, constant gravitational interaction with Earth, constant exchange of atoms with the biosphere. Stop the sunlight, and photosynthesis stops. Plants die. Oxygen production ceases. Within a few years, you run out of breathable air. Stop Earth's rotation, and atmospheric circulation changes. Weather patterns shift. The biosphere collapses. Within a generation, complex life dies out. Change the moon's orbit, and tides shift. Climate destabilizes. The conditions that allowed your species to evolve disappear. You are absolutely dependent on the solar system's current configuration. You're not a human living in the solar system. You're a solar system phenomenon that happens to be self-aware. And sleep is a reminder of this. Every night, you practice letting go of the illusion of independence. You stop trying to control everything. You stop maintaining the fiction that you're a separate entity. You allow yourself to dissolve back into the larger pattern, to merge with the darkness, to synchronize with the cosmic rhythms. And every morning, you reconstitute. The pattern reassembles. Consciousness returns. You wake up as you again. But you're not the same you. Some atoms have been exchanged. Some neurons have been pruned. Some synaptic connections have been strengthened or weakened. You're a slightly different configuration of the same solar system material. The neuroscientist Anil Seth describes consciousness as a controlled hallucination. Your brain is constantly predicting what should be out there, based on past experience, and consciousness is the result of that prediction. When the predictions match incoming sensory data, you feel like you're perceiving reality. When they don't match, you update the model. But during sleep, sensory input drops dramatically. Your brain is making predictions with very little external correction. And this is when the interesting things happen. Dreams are unconstrained predictions. Your brain's model of reality running without sensory feedback, creating scenarios that feel real but aren't. And in deep sleep, even prediction stops. Your brain's default mode network shuts down. The sense of self temporarily dissolves. You cease to be an I, experiencing things, and become just the experiencing itself, without a subject. This is what Enlightenment traditions point toward. The dissolution of the subject-object duality. The recognition that there's no you separate from experience. There's just experience itself, arising and passing, moment by moment, without a permanent observer. But you don't need to meditate for decades to experience this. You experience it every night. Deep sleep is temporary enlightenment. It's ego death and rebirth on a daily cycle. You die every night and are reborn every morning, and you don't even notice, because you're not there to notice. When you close your eyes tonight, when you feel yourself drifting towards sleep, pay attention to the dissolution. Notice how your sense of being a separate self starts to blur. Notice how your thoughts become less coherent, less directed, less controlled. Notice how the boundary between you and the bed, between you and the room, between you and the darkness starts to dissolve. This isn't loss. This is truth. The separate self was always a convenient fiction, a useful organizing principle for navigating the world, but not fundamental reality. And sleep reminds you of this every night. The self can dissolve. It does dissolve. And yet, here you are, every morning, reconstituted, ready to pretend to be separate again. The solar system doesn't need you to understand this. The planets will continue their orbits, whether you grasp your cosmic identity or not. The sun will continue its 5-minute oscillations. The moon will continue its tidal pull. The darkness will continue to fall. But maybe understanding this will help you sleep. Maybe recognizing that you're not fighting to fall asleep, but allowing yourself to merge with larger patterns will reduce the resistance. Maybe acknowledging that the self that's afraid of losing control is itself a temporary pattern will make it easier to let that pattern relax.